Hello, good afternoon, everyone. My name is Swaramadani, and I will explain about the gas turbine cycle. Okay, came to the next slide. Before we start, I will explain about the last session for this model. In this case, we have made the combustion chamber cycle that the component is include for the water stream and also the flue gases, fuel source, and also the flue gases sink. And the main part is the combustion chamber in the center. And we have to set a goal in these experiments so we can run the simulation. But before we run the simulation, we must set the parameter. And the main parameter that I have set is like the pressure, mass flow rate, and also the enthalpy like in this picture. And this is the several parameter for different component. And I have calculated that the parameter itself is about flue gases temperature, flue gases pressure, thermal power loss, air pressure at the inlet, air temperature at the inlet, and etc. And the value of the each parameter is from the journal that I have seen before. So I have gained the value and the results for the sync for the output system is like for the fluid pressure is also 14,000, for the mass flow rate is 1424, and for the fluid temperature is 1227 degrees Celsius. And this is the main parameter that I have want to mention it. So after we set the goals, we came to the same experiment but in different value to see the different output. In this case, I will increase the mass flow rate of the water stream. That the before is 0 for the mass flow rate, and from now I will increasing to the 50 kilogram per second for the mass flow rate. And we can see that the result is different. For the fluid pressure is almost the same, but there is an increasing in mass flow rate. There is a gain 50 degree for the mass flow rate. It becomes 474. And for the temperatures, in this case is decreased. It become 860. Now we can come to the next. It is also the same, but I will increasing also the value of the water stream or the mass flow rate, and I will increasing for the 100 for the mass flow rate. We can see that the value is almost the same for the fluid pressure, and the mass flow is also increased from 400 to 500, but we can see that the fluid temperatures is also decreasing due to the increasing in several value. So we can conclude that the result for the PQ at the output system, pressure and mass flow rate for the output system is increased due to the increasing value from the parameter. But in several component, for the value of the temperature is also decreased. So we can conclude that the value of P and Q is directly proportional, but the T is an opposite and is not directly proportional. Then we can move to the next experiment. So to get the different value and the more efficiency, we made the cycle with the adding several components. In this case, I will add the compressor, gas turbine, and also combustion chamber. But the other components is also the same. And I will set this for the parameter for the flue gases source, water stream, and also fuel mass, and also fuel gases. Okay, we can see the parameter and the results after we simulate this cycle. Okay, I have run the cycle and I will get the result like this. the result like this is got from the same parameter like the cycle before with the combustion chamber. But it just adding for the compressor, gas turbine, and also combustion chamber. And we can see the value is the 7 bar for the fluid pressure, 7 bar for the sink pressure, and 424 for the mass flow rate, and also the fluid temperature is 1308 for the degrees Celsius for the fluid temperature. So I will make the different temperature for each several components. We can see that I've mentioned this for the flue gases, water stream, fuel source, combustion chamber. Basically, it's also increasing in pressure. Like the flue gases is 15 bar, water stream is 5 bar, fuel source is 5 bar, and also for the combustion chamber, I make a change for the mass flow rate. It becomes 400 kilogram per second, like before is 300 kilogram per second. So actually, this all parameters is increasing than before. Then we can see the results of the next slide. So this is the results. We can see that there is an increasing in all components like the fluid pressures, sink pressures, mass flow rate, and fluid temperature is also increased from 7 become 10, from 7 become 10, and for the temperature from 1000 becomes 2000. So the result is we can conclude that the fluid pressure, sink pressure, mass flow rate, and the temperature at the output system is also increasing due to increasing value from parameter in several component. So we can say this is the directly proportional. It is different from before model, like the temperature is the opposite, but in this case, while we adding the compressor, gas turbine, and also combustion chamber, the temperature is also increased. So for the more efficiency system, we can also adding or set the different parameter for the fuel density and also CNH mass fractions. But I think it's enough if we change the parameter in flue gases, water stream, fuel source, and combustion chamber. And it is based from I know. So the conclusion is directly proportional for the result as the simulation running. Okay, I think it's enough, and thank you for your attention.